Hello grade 6, this is Miss Susan. Today's episode is about dot plots and frequency table. Lesson 12-3. And our essential question, how can you use dot plots and frequency table to display data?
Explore how to use dot plots and frequency tables to display data.
This is called a frequency table, and we're gonna represent the data by using dot plots.
Hannah is training for a walkathon. The table shows the number of miles she walks each day. She has 1 day left in her training. How many miles is she most likely to walk on the last day? Frequency is the number of times a data value occurs. Look at the table. Many of the numbers are shown more than once. A dot plot is a number line with marks that show the frequency of data. Let's use the data in the table to make a dot plot.
So, which number is the most likely to happen or to repeat it? So, let's figure it out.
Since the numbers vary from 1 to 6, use a scale from 0 to 6. Plot a dot above the mark for 1 for every piece of data for 1 mile.
Okay, how many times she walked 1 mile? 3 times. So we will put 3 dots.
Since Hannah walked 1 mile 3 times, there are 3 dots above the mark for 1 mile. Now let's plot the data for 2 miles.
So she walked 3 times 2 miles. So we will put again 3 dots.
Since Hannah walked 2 miles 3 times, there are 3 dots above the mark for 2 miles. Now let's plot the data for 3 miles.
Okay, she walked 6 times 3 miles. So we will put 6 dots.
Since Hannah walked 3 miles 6 times, there are 6 dots above the mark for 3 miles. Now, let's plot the data for 4 miles.
4 miles repeated 2 times. So we will put 2 dots.
Since Hannah walked 4 miles 2 times, there are 2 dots above the mark for 4 miles. Now, let's plot the data for 5 miles.
The 5 miles repeated 4 times, that's why we put 4 dots.
Since Hannah walked 5 miles 4 times, there are 4 dots above the mark for 5 miles. Now, let's plot the data for 6 miles.
She walked 2 times. So we will put 2 dots. So now, are you aware why we call this frequency table? Because numbers here are repeated frequently. And we represent the data that how many times each number repeated by using dot plots. So the last number here is 6. 6 is repeated 2 times, so we put 2 dots.
Since Hannah walked 6 miles 2 times, there are 2 dots above the mark for 6 miles. The number of miles Hannah walked most often is the value with the tallest stack of dots.
Which
value has the tallest stack?
Which number that she walked most often? Where is the largest stick here? It's a 3. So this is the number of miles that she walked most often. So the answer for our question, how many miles is she most likely to walk on the last day, is 3 miles.
The value 3 has the tallest stack, so it's likely that Hannah will walk 3 miles on her last day of training.
Let's see another example.
The table shows the number of laps Ricardo swam each day. How can you find what percent of the days Ricardo swam 13 or more laps? Let's unlock this problem.
Okay, we said before, if you remember, percent mean per 100. And this means I want to make a percentages or a relation between the number of laps and the number of total laps to find the percent. Let's see how we can do it.
A frequency table shows the number of times each data value or range of values occurs. A relative frequency table shows the percent of time each piece of data or group of data occurs. Let's make a relative frequency table to find the answer. The first step is to determine equal intervals for the data.
So first, we have to make the frequency table to divide it into groups. So the least number here is, guess it's 5. So that's the least number. The greatest number here is 14, I guess. So we have from 5 to 14. That's a big number to put it into 5 categories. So in this case, I will make it into groups. So let's see how he gonna divide it.
The least number of laps is 5, and the greatest number of laps is 14. So there are 5 intervals with a range of 2 laps each. Next, find the frequency of each interval.
So he made 5 and 6 together, 7 and 8 together, 9 and 10 together, 11, 12 together, 13, 14 together. So let's see how many times 5 or 6 are repeated. 5 is repeated only one time, and there is no 6, so it is only one time.
There was one day that Ricardo swam 5 laps or 6 laps. How many days did he swim 7 or 8 laps?
So 7, 8, another 7, so it is 3. 3 times 7 or
3
8
days. He swam 9 or 10 laps on 3 days. He swam 11 or 12 laps on 7 days. He swam 13 or 14 laps on 6 days. To find the relative frequency, divide the frequency by the total number of data values, 20.
So let's see. What is the number in all now? How many times all numbers are repeated? If you gather these all together, it will give you 20. So now we will find the relation between, or the percentages, is how many times this number repeated. We find the relation between this number and all the numbers together. So we should divide 1 by 20 to find how often, or what is the relation between this number and all the numbers. And this is called a relative frequency. After that, we will find the percentages. Percentage by multiplying it by 100, because I need to divide it by 100 to find its percentage, mean per 100, right? So let's see how we're gonna do it. First, divide 1 by 20, then multiply it by 100.
1 divided by 20 equals 5 hundredths. That's the same as 5%. So the relative frequency is 5%. That means that 5% of the days that Ricardo swam, he swam either 5 or 6 laps. 3 divided by 20 equals 15 hundredths. That's the same as 15%. So the relative frequency is 15%. Ricardo swam either 7 or 8 laps 15% of the days he swam. How can you find the relative frequency for 9 or 10 laps?
By 20, it's the same like here, so it would be for 15%.
Divide the frequency by the total and then find the percent. The relative frequency is 15%. What's the relative frequency for 11 or 12 laps?
Okay, it would be 7 multiplied by 100 divided by 20. So it will be 70 divided by 2, so it would be 35%.
7 divided by 20 is 35 hundredths. So the relative frequency is 35%. What's the relative frequency for 13 or 14 laps?
Okay, it would be 600 over 20. So it would be like 60 over 2, so it would be 30%.
6 divided by 20 is 3/10. So the relative frequency is 30%. So Ricardo swam 13 or more laps on 30% of the days.
Next page.
Lionel kept track of how far he biked each day for 10 days. Use the data to make a dot plot and relative frequency table.
We have 2 here. It's 1 only, so we put 1 dot. 3, yes, we have 2, so we put 2 dots. Then 4, now 4, 5. Yes, we have 3, 5, so we put 3 dots. 6, 1, which is here. No 7s. 8. We have 2 8s. We have 2 8s. Finally, 9 is 1. Let's check and see.
That's right. The 10 pieces of data are placed correctly on the dot plot. You can see that line will bite 5 kilometers the most often because the stack of dots is the tallest above the value 5. The first step in making a relative frequency table is to determine the equal intervals to use. Start with an interval of the 3 distances, 1 kilometer through 3 kilometers. The next interval is 4 kilometers through 6 kilometers. The last interval is 7 kilometers through 9 kilometers.
So
you can use the dot plot to find the frequency of each interval.
Okay, so first we divide it into groups, and it should be equal groups or equal intervals. So the first interval will be from 1 to 3, then from 5 to 6. So afterwards it will be from 7 to 9. So each one interval to be three numbers, okay, or 3 spaces, okay. So let's count the frequency of each group or each interval. So the frequency here, we have 3 dots, so it is 3. So we write here 3. The frequency here is how many dots in this interval? It will be 4. So we write here 4. The last one is the third interval is 3 dots. Now let's check.
Correct. Line will bite 1, 2, or 3 kilometers 3 times. He bites 4, 5, or 6 kilometers 4 times. He bites 7, 8, or 9 kilometers 3 times.
So
now find the relative frequency for each interval.
the relative frequency is the relation between the frequency of the number and the total frequency. The frequency of this number is 3, and the total frequency is 10, because 3 plus 4 is 7, plus 3 is 10. So we divide 3 by the total 10, and we multiply it by 100 to find the percentage. So first, 3 multiplied by 100 will be 300. 300 divided by 10, the total, so it will be 30. So this number is 30%. The next one is the relation, relative frequency, means the relation between the frequency of the number and the total frequency. So the frequency of the number is 4 and the total frequency is 10. So then we multiply by 100 because I want the percentage. So first we multiply 4 by 100, it will be 400 divided by the total frequency 10. So it will be 400 divided by 10 would give me 40. The last one, again, the relative frequency is the relation between the number frequency and the total frequency. So the number frequency is 3 and the total frequency is 10. Then we multiply by 100. Why? Because I want the percentage. So again, 3 multiplied by 100 will be 300 divided by total frequency 10. So 300 divided by 10 is 30. And if you add all together, it will give you 100%. So 30 plus 40 will be 70%, plus 30 will give you 100%. And this is the total frequency percentage. So let's check and see.
That's right. Since there are 10 pieces of data, you can divide 3 by 10 and divide 4 by 10. Then you can find the percent for each interval.